and welcome. You're listening to episode number 55 of the podcast at the Crossroads of the Safe Network, right here at safecrossroads.net. I am your host, John Ferguson, the simpleton of Project Safe, because not everybody can be a geek. Oh, how much I'm not. But this is a pivotal thing. I have explored enough to really know and see the importance of the work being done here, and I'm just here to share it from a simple perspective that everybody can, or that a lot of people can really understand. We go deep, but I cannot deal with the bare metal. That's why I beat my head against it and try and understand and reflect it back to the people who really do know, and somehow we gain a better understanding. Safe Network. Let's do a brief cover of what that is. Safe Network is, well, it's a project by MadeSafe, which has been working on this for over 13 years now. It is the design of a perpetual web, basically, that is an autonomous data storage and communications network that has no central servers, no central points of control, but has persistent data that will always be there, that's made up of everyone who contributes resources to the network and is rewarded for doing so. It's a whole ecosystem, and its design is for secure access for everyone with privacy, security, and freedom. SAFE, secure access for everyone. Pretty cool. So that's the brief overview. If you really are new to the network, I would recommend a few things. One, go to safenetwork.tech. That is a really good introduction to the network. That will lead you off in many directions, including to some community things like safenetforum.org. That is where you can congregate, ask your questions, an incredible community. So today we're wading in pretty deep, very broad here. There's so many things here that are interconnected that it's going to be an interesting conversation. We're going to talk about the recent release regarding the vaults. In other words, the basic node structure of the network as it goes forward. And to do that, we've got two return guests. Nikita Baksalyar was with us back in episode number 45. And in that, we talked about the connection layer of the network. Anyway, you can go back and listen to that. It was a great interview, but things have shifted and changed. Nikita, welcome back to the Crossroads.
Hello, John. I'm happy to be back.
Good.
And talk to you again.
Yeah, well, this has been good. We've the three of us have talked a little bit over since yesterday and today, and it's been a lot of fun. Cut out a lot of work for me over the last 24 hours, digging into details which I had not been tracking. It gets out of hand so quickly. In terms of, especially for someone who's not, immersed in it. If you skip a beat, it can be hard to catch up.
It can be hard to catch up even for someone who is immersed in it.
You're right. Well, we're right. Well, that's the kind of project it is. It's so interconnected. Now, I just want to touch on, when we talked in episode number 45, we focused mainly on the connection layer of the network, which the programming language that the Safe Network has adopted at its core level is Rust. So it was connections in Rust or connected Rust, whatever. And that was the area you were excelling in. Tell me, actually, in episode number 53, we covered something that really shifted in that. And that was with Spandan Sharma. That was a great episode. People can go back. But would you briefly tell us the shift between Crust and the new Quick Network and the significance that has in relationship to what we're going to be talking about today on vaults?
Sure. Well, to put it simply, the main reason behind this change is just not the change for the sake of it, but it has a main reason, and the main reason is we are not doing things just to do some things by ourselves. We do things because we need to deliver the working network, right? And we designed and developed Rust at the time when the Rust ecosystem was not very mature, and in fact it was very young, and it didn't have a network library with characteristics that we needed at that time, with a networking library that delivered that addressed the requirements that we needed. And we decided to code our own library, which was Rust. But as the time passed, there have sprung up some more efforts in this area, and there now are many more options to choose from in terms of the networking libraries. And as we are constantly monitoring the space, and as we are working on the networking library, we also decided to give it a try and to see whether this new library suits our needs. And as it turned out, the library that builds on the protocol and that is called Quick, fit our needs almost perfectly, because it's something that was developed at first only at Google, but now it's became an IETF standard, meaning that it is something that a lot of companies and a lot of organizations across the world has agreed that it is something that we should standardize and make it almost like a fundamental level of the internet, on par with TCP/IP and other network protocols. Meaning that Quick currently has this draft status, meaning that it is being developed, but eventually it will become the foundation of the new internet protocols. It will become the foundation of one of the main protocols on the web, the HTTP protocol. And from that point of view, we decided that Quick is almost exactly something that we were looking for, because it is a standard protocol that a lot of people work on, and it is also a protocol that has an built-in encryption, which is of crucial importance for us. And for details why it is so important, you can listen to the previous podcast. But basically, this gives us also an important advantage, because once we start using not a custom-made protocol, but a protocol that everyone agrees on using, the traffic of the safe network becomes indistinguishable from the rest of the internet traffic, meaning that the safe network becomes almost like hidden within the common internet traffic. So with that, the safe network effectively becomes uncensorable. Because if you want to censor the safe network, you will have to censor the entire internet, because the entire internet will be building on these fundamental protocols. So you can't prohibit the safe network without completely prohibiting the internet itself, which at this point in time, I think is not feasible even in the most oppressive countries in the world. So that is one of the most important things that we were looking for, and Quick delivers on that.
That's really good. The thing that I like about it is that there is this general motion for the internet to be encrypted by default and so forth, which really is a move forward in general for internet stuff, and that requires less out of the safe network stack.
Exactly.
And that has a big effect on the... Now, I know Crust, in order to do what it needed to do in terms of making connections and so forth, really had to rely a lot on the next layer up, which was the routing and vault network. And that's part of where it really fits into what we're talking about today. Could you briefly reflect on that relationship of how that relieves the safe network stack itself of a whole lot of complexity and makes it much more straightforward to do what we're trying to do?
Sure, I'll give it a try. But essentially what I wanted to add to what I said previously is that using something that is common and understood by everyone and that is being developed by everyone, we basically do not care about the networking layer anymore, because we can focus on the things that are more important to us now, that is the working network and the routing inside of that network, because this becomes a solved problem for us, the underlying network protocol. And that leads me to an answer to your question. So basically, the fundamental network level is concerned with the most basic network features. So you have, imagine you have 10 computers, and you need to connect them all within the network. That is the basic network level that solves this problem of connecting the devices across the network. But this doesn't really solve the next fundamental problem and the next fundamental constraint that we have in the current internet infrastructure, and in particular the current web infrastructure, because how it is structured currently is the common client-server model, meaning that essentially how you currently use the internet is you have your client, your mobile phone, or your computer, you launch a web browser and you visit a website like google.com. And behind the scenes, what happens is that your computer connects to this website and connects to the computer that basically your request is served by a computer in the data center of Google. And that is a very fundamental thing, and that is a very fundamental aspect of the current internet infrastructure, because it gives a tremendous amount of power to those companies and to those persons who serve as the servers, as the backbone of the current web. Meaning that all the information that you publish on the internet, all the information that you request from the internet, it goes in this client-server way of interacting with these parties. And this gives them a tremendous amount of power, because they can see which kind of content you request and which kind of content you put there on the network. And just knowing that, they can basically, as a consequence of that, we have all the problems that are pervasive to the current internet, like the privacy breaches, the stolen passwords, and the problems with the
surveillance.
Surveillance, yes, the advertising networks, which are essentially the spying networks, which collect information about you. So that the problem that we are trying to solve with routing is this exact fundamental problem with the internet. It's the model of how you connect the computers and the clients. So with the safe network, instead of that, we have a network of computers which comprise basically we have a network where everyone is a client and everyone is a server. So with that way of connecting the computers, no one single actor, no one single machine can have much more power than everyone else. And no single server has more power than you, the user of the internet. So it gives back the power and the control over the way you use the internet, and over the way you publish and use your data back to your hands, just by restructuring and re-envisioning the way we see and understand the network model in the internet. So that's the routing, and that's one of the fundamental components of the safe network.
That's fabulous. That is a great setup, because that makes it really clear that basically anyone can run a meaningful vault or meaningful storage and interaction level of the network at a contributory level, and anyone can also be have a client that addresses the network as a whole. Now that leads us into the key element of that, which is the vault, which is what we're really kind of focusing on today. So I'm really pleased with that breakout, because it leads us right to this. The vault structure, how these nodes interact and so forth, is what constructs the logic by which this all interacts. Now, you can't just that logic, that security, that ability to come to consensus is a rather involved and complicated thing. I don't have to be an expert to know that. I've beat my head against it quite a bit, but understanding that is probably all the details. That's probably beyond the scope of what we're going to do today. But to help understand the vaults, and there's so many aspects of this. We also have today Lionel Farber, who was with us in episode number 50. Lionel is a developer in the Chennai, India office of MadeSafe. It's a satellite office in Chennai, India. And when we had him on episode number 50, we were talking about app development for mobile, specifically in that case, native Android development. Lionel has shifted many things. I tell you what, Lionel, welcome back. Welcome back.
Hey, John. It's really great to be back here.
Yeah. Well, you have expanded quite a bit in your scope. But before we go there, I wanted to touch base and say, how's it going there in the Chennai office? I was hoping to do an episode at one point about that, and I still hope to in terms of that remote office. Could you give us an update on how things are developing there?
Well, things are absolutely great here. That we had a lot of new joinees who joined us in December, and they have also started to contribute a lot towards the network. I think if you had a look at the forum recently, you would see that we recently released the mobile browser for the Safe Network, and that is from the mobile team that we have at the Chennai office.
Cool. Now you've one thing I notice about the developers with MadeSafe is you might tend to think of them as working in one area or another, but because of the interactive nature of all the different pieces, you can't stand in isolation as a specialist in one thing, so guys tend to move around. I know that happened with Nikita, and it's happened with you. So you've shifted more into a broader scope, which is why we're talking to you today about vaults. Could you kind of give us an idea of that shift, just as a point of orientation before we dive into or maybe diving in is going to be part of that? But I'll leave that to you to see if you can fill in if you understand what I'm asking.
Yeah, sure, definitely. So when I joined as an Android developer, and we built a set of libraries that could help you build native Android applications for the network. And we released that in January. And after that, we had planned to move towards the new set of data types. And all the data types are defined and in the client libraries, that is safe client libs, which is written completely in Rust. I didn't know Rust when I was asked to move to that, but then thanks to a lot of help that I got from the team, and it was a really amazing learning opportunity, and I was able to move from Java to a completely different technology and contribute to that module of the project. So right now I work in Rust, building the safe client libs and a little bit of the safe vault that we just released recently.
Cool. So you deal on both sides of the interaction of the clients with the vaults, so you have to have an understanding of both ends. And so that really makes you a good person to talk to about this today. Hey, just for you guys and the listeners, this is a daunting task to wade into all these things, and these guys have been very helpful bringing me along. Hopefully we can share an experience here that'll give a pretty good idea of where we're going. So the kind of the impetus of this was the release of recent, in the last week or so, of what are we going to call it? Real vaults that individuals can run. Now, to get to what that even means, I'm not sure the best way to go about it, but I think we have to talk just real briefly about, as I mentioned, the logic and the structure of the network, and that brings in the consensus protocol and the dance of these independent nodes in arriving at a meaningful, secure, and perpetual storage of data. Let's not go too deep to that, but could you tell us the function of the vault in the network as an ideal, and then we'll have to get into, well, how do we get from not having those to having them, and then where do we go from there? I'm just throwing the ball up there and hoping you can knock it out of the park.
Yeah, sure, John. So, as Nikita was mentioning before, in the safe network, we don't have a single person who holds all the data. So everyone is a server and everyone is a client. So this server, what we call in the safe network, would be the safe vault. So everyone who wants to contribute to the safe network can run a vault from their computer, giving a certain amount of resources towards the network, and they get rewarded for it. So this would be the vault that you run, and you get safecoin based on how much you contribute to the network, and we call this farming. So these different vaults, they talk to each other, and it's not one person who makes the decision. So if a client asks for something, he doesn't ask a single person. He asks a group of people, a group of vaults, and these vaults talk to each other, and they come to agreement, which we call consensus, using the PASIC protocol that the routing team is building. So these vaults talk to each other and come to a decision using PASIC, and then give it back to the client as a response. So it's a collective decision made, not by just one single person. So there's no single point of failure. Now, as the routing team is working towards bringing PASIC and making this secure communication between vaults, we decided to start building the vaults in different phases. So what we just released, we call Vault Phase 1, where there's a single vault. It's not a group of vaults yet, but there's a single vault that can handle the different client requests and send and receive data using the new data types.
Wow, there's a bunch of potential branches there. I think what we need to do is now that we've kind of established, okay, well, the vault is the core logic and functioning of the network, as opposed to the client, which is the user. That's the software that represents the user's direct interests. So this is Vault's Phase 1. Previous to that, what have we been operating on? And I think this gets into the mock networks of having a mock vault, mock client. So let's walk through that progression. That I think that will give if you can kind of set the stage and give the idea of how we evolved from that to this, and thus really I think we'll get an understanding of the significance of this new release. Because when I looked at it, I said, oh, well, that's nice and interesting, but I didn't actually understand the significance of it until I plowed in a bit, and I think we can shortcut that process for some people if you know what I mean.
Yes, sure, definitely. So previously, we had the mock network that people could use to test their applications and stuff. So the mock network isn't actually a network. There's no client and there's no separate vault. It's just one single process. And when you run an application on the mock network, it just sends and receives data to a file, which just sits there on your computer. So it's not actually a vault. But what we've done now is we've built the vault that we would, at the end of the day, you're going to be running this vault on the network. But it's not a group of vaults yet. It's just one single vault, and a client would connect to the vault either locally, or if it's a vault, we also have a shared vault that we've hosted. So a client can connect to either of these vaults using the new protocol, Quick P2P, and send and receive data to this vault. So there's an actual running vault, but it's just one vault right now. And we use the new protocol to send and receive the new data types and all that.
Okay, so this has been a development that's come over time. I'm going to run by my understanding as I wrote down and worked this. We started out with mock clients and mock vaults, in other words, to get the function. And then we moved to real client libraries. In other words, these are the client libraries that actually are the whole underlying structure of the clients, but that was run against a mock vault, which is just a file that emulates what it's supposed to look like. And now we're up to the point of having the real client libraries functioning against a real vault library, even though it's just local. Is that a kind of valid breakout?
Yes, it is.
Okay.
But this single vault, it doesn't necessarily have to be local. For example, you can run a vault, and I can connect to your vault send and receive my data. So it doesn't have to be on my computer.
Oh, I got it. Oh, okay, cool. And that's what is being done now on this particular branch of the test network. Now that leads up another question I want to bring in because it might cause confusion. We've had the Alpha 2 network, and my understanding of this, and I might be wrong, but basically what we've been dealing with there is a set of vaults running in the cloud hosted by MaidSafe, just to give the function. Most of those functions are already running, or is that really just a bunch of mock vaults that are interacting together?
Do you mean the ones that we have running in Alpha 2?
Yes, the Alpha 2, because that's been running for over a year, and it's been very interesting, and I know there's self-encryption, self-authentication, and so forth. It's permissioned at this point, but still, as my understanding, and I want to, if I've overstated that or over-considered that, I want to be corrected. But as my understanding, we're talking about two different things here. We're talking about the Alpha network, which is being maintained still separately in order to interact amongst people, but that's all hosted, but it's basically vaults.
Right,
is that correct?
Right. So the Alpha 2 network, they're not mock vaults. They are also actual vaults that they are a set of, I think, around 200 vaults that run on a cloud that's hosted by MaidSafe. And it has routing as well. So when a client sends a request, there's a certain amount of voting that happens before it sends a response back to the client. But the Alpha 2 could not handle vaults from home. It had to be a set fixed number of vaults that run by MaidSafe.
Right.
But this is completely separate from Alpha 2, and Alpha 2 uses Crust. This one uses the new protocol Quick P2P, and we also have the new data types and safecoin in this mock vault, in this new vault phase 1.
Oh boy, you stubbed our toes there on that one. I tell you what, we'll get back to the data types and safecoin specifically in just a moment. But so I think that's good. So basically, the Alpha network is a stage of development which has allowed a lot of the client interaction and the logic of the network, the logic of the routing to be honed and worked on, and that's actually been pretty solid for a while. But here we're talking about bridging into vaults from home. And then we're actually starting to talk about the foundations of building the real in the wild network, which isn't quite there yet. But am I right in saying that this is a huge step forward in this Vaults Phase 1 of being able to run actual client libraries and actual Vault libraries, even if on a limited basis?
Yeah, you're right, John.
Okay.
We can already run actual vaults and actual client libraries against each other. So now that we have a vault, and the routing team is coming close to having a way for vaults to communicate securely. So when we have those two components ready, all we have to do is just put them together, and then we can have a set of vaults that can communicate to each other and then send responses to clients.
I can probably provide another perspective on this, just to put things in the context as to why this Vault Phase 1 release is important and why we are even talking about this. It is important because solving this problem of clients and server model of interaction on the internet is not the only thing that we need to do here. It's only a part of the problem, because solving the routing wouldn't give you all the functions that you are familiar with on the internet. Meaning that we need to rethink almost all the things that you do on the internet and the web from the bottom up. Meaning that we can't use many of the existing protocols such as HTTP, because they are ingrained in this client and server mode of interaction. And we also having this experience and knowledge in how the internet was built and how it evolved, now it is apparent that some of the things are missing from the internet, and some of the things would be very nice to have, such as, for example, the payments and the integrated payments on the internet. That gives us the challenge, but also the a very important possibility to rethink and rebuild some of the things from scratch, essentially. And the Vault Phase 1 gives the taste of how the new internet might look, or how it could look if it was built in the way that we built it. So it gives you the preview of how the internet would have looked if it was designed in this way. So that now you have the different data types, the safecoin, the payments, and the perpetual web, of course. So that's to put the things in the context.
Well, thanks. That really helps, because that really is something I caught on to very early on, that we have, just by usage and familiarity, we have these fixed ideas as to how things basically are, which don't have to be that way. And what the Safe Network is doing is shifting some underlying assumptions about what ought to be and what can be, and is building something very, very different. So and I don't know who best to take up this next angle, whether it be Nikita or Lionel, but that brings us back. You both mentioned it we've mentioned the new data types and SafeCoin, which SafeCoin is just one data type. It's really that simple. As I've said earlier, it's like, putting too much focus on SafeCoin is missing the point, because SafeCoin is basically, you look at all of the data on the Safe Network, all of the communications on the Safe Network are designed to be handled and secured to the absolute level that you would want to secure your money, your coin. And so let's move into whatever discussion we need to do about the new data types. And that's a deep subject, and there's many different aspects I've discovered, that we could go down. And there are, various little decisions to be made here and there, big and little, I'm sure. But let's talk about data types and how that relates to what this Phase 1 Vault release is, and then SafeCoin actually comes in there a little bit too. So who wants to field that? Lionel, are you best for that?
I can take it if you'd like.
Okay.
So earlier this year, we came up with a few RFCs for the design of the new data types. An important fundamental that we have for the Safe Network is that data should be stored in perpetuity. By perpetuity, we mean permanently. So data that you publish on the network is essentially its knowledge that you're giving to the people. And once you give knowledge to the people, you shouldn't take it back. You shouldn't be able to take it back. And you shouldn't be able to modify it either. So this is published data. And of course, your data, your personal data that you want to store safely and securely, you can have it as unpublished data and then delete it whenever you want to. So for this, we came up with a set of data types, published and unpublished data types. So unpublished, we have three variants, which are append-only data types, which you can use for storing version data on the network. And you have immutable data, which is basically you can't append to it, but once you store it, it's just there permanently. And we still have the previous mutable data, which is data that you can change, and since it's mutable, it cannot be published. And you also have unpublished immutable data, which, although it's immutable, it's unpublished, meaning you can have it or you can share it with a bunch of people, and only they can access it.
Well, that's actually a big deal.
Yeah, it is. It definitely is. And it's an important step that these data types are taking. It's a big step towards the perpetual web, because the perpetual web is something like what we want to have, like Internet Archive, which stores the archives of different sites over the years. And this way you can roll back to any version of a site and look at what it used to look like previously. So that's what we want to have baked into the Safe Network from the start, because any type of data, for example, let's say I'm publishing an academic paper, and I publish an initial version for everyone to see. And later, I don't want to take this off, because what if someone has started their research on it and all of a sudden it's gone missing? Then that's a problem. But I can still update it, saying, okay, I made some changes, there have been some flaws, and I want to update it. So I update it to version 2. But version 1 is still out there. So anyone wants to say, okay, this is how it started, and it's been updated to this. So he knows what happened, what the drawbacks are, and he can go through the different versions of that particular paper and understand the whole flow and where it started and how it grew to where it is today.
Cool. So and yeah, that is really good, and there's a lot of details there that we could break out. But so these are new, some additional data types that have just been. And they're just being evolved and set in place. How does that relate to the establishment of this vault phase 1?
Right. So the phase 1 vaults are equipped to handle these different data types. So clients can start sending requests for different kinds of data to be published on the network or unpublished and fetched securely. So this way, people can already start building applications that use these new data types. And once we have the entire network in place, they don't have to do anything on their side because the application is already built. And they can just maybe update the set of libraries and just run their applications against the whole network.
I had a thought when you were laying that out that it was really, really cool regarding the impact on history of actually maintaining history in the form of a perpetual web. You know, it's kind of like the victor always writes history. That's kind of a truism about how things have evolved. So you grow up with a particular representation of history. It's not necessarily what actually happened from all viewpoints. It's the accepted. It's the truth according to the victor, and rather than just the truth. Which, you know, whether the full truth is ever discoverable or not, there's always different perspectives, and this allows for one to form one's own view of history by looking at whatever sides of it one would have. I mean, this is true of the evolution, say, of a website, but I had never thought about it really on the depth of, but, you know, from history going forward, once this network is established, we have a whole different access to data and information than has ever existed before. And I hadn't anticipated that insight, but I just had it, so I thought I should share it back. It makes this step of really establishing these vaults and then continuing to develop the network really pivotal. Any feedback on that?
That's a great way to look at it, John. I see you're enlightened by the fundamentals of the networks.
Well, I got that. I got a lot of the pictures early on, but that one just hit me between the eyes. So anyway, we won't dwell on on that further, but it really does reflect the import of, well, what is this network all about? So we've got the data type. I'm not sure what more we need to do on that. That is a whole study in itself. I think we should reflect back, perhaps on. Now that we're establishing real vaults with real libraries that are then going to have to grow up and interact with each other, then we get into the logical structure and, I guess, secure communication between nodes, but also then between sections of nodes that are operating together, so that they can rely on, so that all nodes can rely on data coming out of those sections. And the logic that builds up, and that all centers around Parsec. So I think there's other episodes on Parsec, but I think we need to go back. Now, which one of you two is going to be best to just talk about Parsec in relationship to the vault structure evolving? Nikita, have you got some perspective on that you'd like to share?
Yes. Well, in simple terms, why we need Parsec is to just reach the consensus, but understandably that doesn't tell a lot because it's a very broad term, right?
I'm sorry, I'm going to chime in. I think for those that aren't familiar, you can look more, but Parsec stands for Protocol for Asynchronous, Reliable, and Secure Consensus. It is an asynchronous protocol that's now pretty much fully asynchronous, which is a huge deal. And for for anybody who that sends up their antenna, you should look back and check it out. But it's basically the system by which all of these various nodes can agree on the sequence of recorded actions. So anyway, I just wanted to chime in and put that definition underneath. Sorry to interrupt you. Carry on, Nikita.
No worries. But yes, it's just as you said, it is a system that allows us to essentially to have the similar worldview from different parts of the network. Because essentially what we have with the client-server model is that we don't really, we are not really concerned about the consensus or anything like that, because in a simplified terms, we are dealing mostly with two entities, the client and the server, right? And if there are multiple servers, you can introduce the consensus on the level of a data center, of an organization, but generally those servers don't need to interact with the internet or the network at large, right? But now with the model that we have with the safe network, anyone can be a server and anyone can join the network, meaning that they have the full power and the full control over the actions that the clients can do, which gives the one of the fundamental problems that we're trying to solve with the development of the safe network is the malice, meaning that as long as anyone can join the network, it also means that the actors that are not trustful can join the network, and you wouldn't want to really trust your data, your private data, or your coins or safecoin to the actors who are bad, right?
Or the writing of history. Bad guys write history way too often. Anyway.
Yeah. You don't want to give the. It's almost like a contradiction. You want to give the users and the worlds the full control over the network, but you at the same time you don't want to give them too much control, because if a vault is not honest, if it's not an honest participant of the network, it can start giving you the false answers and can start behaving badly. To prevent that, we need to reach the consensus. And it's not only because of that, it's also because, basically, you need to, it's for many reasons. One of the reasons is that, imagine, you joined the network, but for whatever reason, you can't participate in the network anymore, but you're completely honest, you are a valid member of the network, but for whatever reason, you decided that you don't want to do this anymore, and you leave the network, right? But imagine that you stored someone else's coins, and now they can't access their coins because you already left the network, right? It poses an interesting question, an interesting problem, because we can't store the data and we can't store the information only on a single vault. We can't trust a single vault to do that. And for that, we duplicate the data across multiple vaults. And to make sure that all of the vaults have the same information, we also need the consensus. Meaning basically that if you were paying someone else with your coins, you want for all of the vaults who hold your coins to have the same information about it. It's not like one of the vaults thinks that you have 10 safecoin and the other vaults think that you have 5 safecoin.
Right.
It means that all of the vaults need to have the same information about the data they store, and that is also why we need the consensus. So it's a lot. There's a lot of reasons for that, and Parsec is essentially solving that problem, providing the same view on the state of the data and the state of the network to all of the participants.
Right, and then that really, that breaks out in a lot of directions in terms of general understanding, but the unique structure of the safe network allows more discrete sections of responsibility to be broken up so that consensus can be arrived at very quickly at a very granular level. So not only deciding what coins go where, but what data gets to be stored. And in the case of a couple of these new data types, who even gets to access certain chunks of data. So, I mean, the granularity of this is really remarkable. And I just wanted to touch on that. I don't want to, a whole episode on Parsec, and all of these different things deserve their own. In fact, there is, if you look back through the Safe Crossroads, we've addressed Parsec a couple of times. I just wanted to touch on it because it's so vital to the actual construction and integration going forward of all of these real vaults into organized sections of responsibility for the data. So who wants to take up what the progression is here? So now you can run a real vault, and people can address it, or you can use it to interact with the network. How does, just without getting into too much detail, how is this the first step of progression to actually developing an entire network with various sections that are interacting to handle all of the data and store it and so forth? Lionel, you want to take that up?
Sure, John. So as I mentioned before, this is phase 1. So we have a single vault where clients can send and receive data to. Now phase 2 is basically it's going to be a set of vaults, but we're not planning vaults from home in phase 2 yet. So as the routing team is building the routing component that can help vaults securely communicate with each other. So once we have those in place, phase 2 will be a fixed number of vaults. That would be a single section. So phase 2 is going to be a single section that would again be hosted by MaidSafe, and every request that goes from a client would go to this set of vaults, and those are going to vote using Parsec and process the request, and the response again needs to go through Parsec to make sure that the response from the different vaults, as Nikita said, the data that the different vaults, it's duplicated across different vaults, and all this data has to be the same. So that goes through the entire voting process again, and then goes back to the client. So that would be the next step, a set of vaults that process requests using Parsec as well. So the routing component comes into play here.
Cool, and then that is just designed over time to build into multiple sections, and secure message relay is coming along. There are so many different directions. I think that probably gives enough of a foundation for people to understand how the importance of this and how things are generally going forward. For more detail, you're going to have to dig more than we can cover here. So there were just a couple of other newsy things that I wanted to, not newsy, but relevant that I wanted to cover before we wrap up, which is, here's the elephant in the room, SafeCoin. How is it that SafeCoin is now integrated into these vaults? SafeCoin in its real sense can't exist broadly until the whole network is really coming into being. But we have some experience regarding that, regarding the wallets, regarding. Tell us about how SafeCoin is integrating into this right now, because that was coming fast. That came faster than I expected.
Right. So in the Alpha 2 network, we wanted to limit the number of data that a user could store on the network. So we had the concept of puts. So every time you store something on the network, a put is reduced from your account. So as I mentioned before, we introduced the new data types that the Perpetual Web, and people can start building applications for this Perpetual Web using the new data types. And just like we need applications for the Perpetual Web, we're going to need applications for SafeCoin as well, to handle SafeCoin transfers and a lot of stuff that you can do using a balance or a wallet. So we introduced test SafeCoin. So basically the vault is coded to handle these SafeCoin transactions. Again, it's just a single vault which can handle these different SafeCoin transactions, like creating a new wallet, storing some coins, sending coins to someone else, and all that. And at the same time, we removed the concept of puts, and we replaced it with SafeCoin payment. So whenever you store data on the network, you pay a little SafeCoin, and you use it to store data.
Oh, yeah. Now, we're going to have to touch on this since we've gone that far, because previous understandings of safecoin was that they were digital entities. In other words, it was something that that existed as an address. Now, that's going to take a whole other thing, but there is, with the development of the potential logic of the network and the security and consensus regarding kind of account-based quantities of safecoin, we can go completely fractional with safecoin. So storing a bit of data might be 100,000th of one safecoin or whatever it works out in the network algorithms to be at that time. I think we needed to mention that because otherwise it could cause confusion. And I think we better just go, okay, we can experience that in dealing with the vaults now in terms of how that's going to be. Is that safe to say? Just from a more of a user interface perspective?
Yeah, that's right. So a safecoin is basically, as you said, it's just data at a particular location. So when you send a request from a client, and it's a safecoin, it's a request that requires some safecoin operation. For example, sending money to someone else or paying to store data. It would first go to that address where your safecoin lies and make sure you have enough safecoin to do that transaction. And only then your request is forwarded further towards the data handlers, which basically handles any data operation. And if it's a coin transfer, it will happen right there. So it will go to that address, make sure you have enough safecoin, and then process it and send back. So all this right now for the phase 1 vault can be done using the CLI applications, the Safe CLI.
Command line. Oh, good. CLI, command line interface. That was good. I was wanting to integrate that as the next step. I didn't realize we were going to have a segue. So just to wrap up regarding generally on SafeCoin, this is all still stuff that there's many aspects of this, and it's not like, okay, SafeCoin is now in play, but the beginnings of it are. So we're going to leave that right there. Anybody who really wants to dig in, there's plenty to dig in on, and it's pretty cool. So, but you mentioned, tell us about the Safe CLI, Safe Command Line Interface, and where that's at and the importance of it.
So this command line interface is something us developers are very, very familiar about. For some of us, it's like the most favorite thing. Like if we have a command line, we have everything that we need. So since it's basically the command line interface is basically it's a foundation for any type of application that you run on your computer. So if you have something running on a command line, extending it towards a user-facing application would be very, very simple. So that's why we decided to go this route. So we took a command line route, and you can use the command line to create a wallet, to send money to someone, to store data, and even publishing a website via the command line is very, very easy thanks to the team. So you can do all of that now using the Phase 1 vault, either locally or the shared vault.
Wow. Well, you know what? I don't know that there is a good wrap-up for this for this as an episode. So we're going to, unless there's something that either of you or both of you would care to share that there's some point that's been overlooked. Actually, let me just ask that, Lionel, anything you feel like we need to wedge in here toward the end?
Yep, there is one more thing.
Oh, okay.
So I spoke about how easy it is to publish a website. And we also spoke about taking a step towards the Perpetual Web. So the team has already put out a proof of concept browser that is a POC for the Perpetual Web. So basically what you can do right now is you can go create a website. Let's say you're publishing this podcast on the website. And you publish it and everyone can see it. Now, let's say there are a few mistakes on the site. Let's say a spelling mistake, or you're going to change the theme. You can go to the website, you can change everything, change your code, and you can upload the next version of the website. So the browser right now is already capable of switching between the different versions of the site. Of course, it doesn't have all the features that the previous Alpha 2 browser has, but we've already taken an important step towards Perpetual Web. So you can already browse through different versions of a site.
Oh, that's fabulous. That's fabulous. Nikita, do you have anything to say in final recap here?
Yes, sure. I would suggest reading there is a Medium post on that is duplicated on the Safe Network forum, the community forum, that lists all of these, all of the things that we have talked about during this podcast, but in much greater detail. So if you're interested in any particular topic and you want to explore it more, I would suggest going there and going to the Safe Network Community Forum and reading about it there, because there is always many more details to the topics we explored, and I think it's even fair to say that we only touched upon some of the subjects, because there is so much more to that.
We can only branch in so many directions at once, yeah.
Yeah. Because the topic of the perpetual web is so vast, and so there are so many implications that it's discussing it all in 1 hour is it's a very small amount of time.
Oh, yeah. No, that's great. Well, I think we've done a reasonable job here of pulling this together. I know that when I, especially when I've kind of been out of the loop and I'm not right on top, and so many things have happened in the intervening time that I had to pile in, and it kind of warps my head trying to catch up. But I think we've done a really good job. I'm really excited about. I did not myself completely grasp the impact or the significance of this particular motion, and hopefully we've done a good job of putting that forward for people to make up their own minds about. I thank you guys so much. As always, you and the rest of the team are so good about trying to help and nurture and bring along understanding. So I really appreciate it.
Thanks for having us, John.
Well, I hope to have you all again.
Yeah, we'll be happy to come back. It's been great having a chat with you, John.
Good deal.